Hello and welcome guys. This is the lecture number 2 of quadratic equation. So before starting this topic, I'm introducing myself that I'm Tushar Kumar and I'm now studying MSc in Mathematics and Computing at IIT Hyderabad, and I have 2+ years of teaching experience. So let's start the video by showing you a question related to the quadratic equation. And can you please tell me what is the solution of the quadratic equation? So please start the solution. So here it is given that if the difference of the roots of x square minus px plus q equals to 0 is unity, then these are the 4 options given to you, right? So here the important term is difference of the roots, right? From the previous lecture, I have already told you that there is exactly 2 roots exist for a quadratic equation. So here the quadratic equation is given to you is x square minus px plus q equals to 0, right? So let alpha comma beta are the 2 roots of the quadratic equation. So according to the information, we can say that the difference like alpha minus beta is definitely 1, because it is given that the difference of the roots of this particular quadratic equation is unity. So we can write down alpha minus beta equals to 1, right? And also by the relation between roots and coefficients, relation between roots and coefficients we can say that sum of the roots, which is alpha plus beta, is equals to, we know, right, b by a. I mean minus of minus p by 1, which is definitely p. So alpha plus beta will become p, right? And the product of the roots, which is alpha into beta, will become q by 1, which is q, right? So here you can see that the sum is p and the product is q. So we will use this information later on. So before using this particular terminology, let us first completely trying to make this alpha minus beta in terms of alpha plus beta and alpha beta. Since alpha minus beta equals to 1 is given to you, right, which is alpha minus beta equals to 1 is given to you. So we can square on the both side, right? So this will become 1 square. So I'm write down here, which is squaring both sides, right? So we'll get, obviously you can break this particular term. Otherwise you can apply a formula which you guys already know, that alpha minus beta whole square can be written as alpha plus beta whole square minus 4 times alpha times beta, right? And this is 1. So we'll get this particular term from this. So here you can see that sum of the root is there, product of the roots is there. So we have already have the value of alpha plus beta and alpha beta. So we can plug in these particular values in this particular equation, right? So putting alpha plus beta and alpha beta in 1, right? So we get what? Can you tell me again? Which is p square minus 4 times q, right, which is equals to 1. So here you can see that the option number B is exactly same as this particular option, right? So definitely you can't say that this option will be correct, because A option is not correct, because we can't make this particular expression as p square plus 4q equals to 1, right? But B option is exactly same as this particular option. After that, we can actually trying to make this particular expression either this expression or not, or either this expression or not. This is actually a MSQ type question. You know, right, what does it mean? MSQ means actually multiple select question. So this question has either one correct option or more than one option, right? So we are just trying to make this particular expression into either this form or either this form. So here, you know, right, what is the value of p square? P square is nothing but 4q plus 1, right? Here, you know, right, p square equals to 4q plus 1. So we are just trying to adding by 4q square on both sides, right? We are just adding 4q squares on both sides, right? So then we will get p squares plus 4q square definitely equals to what? 4q plus 1, right? Plus 4q square. I'm just trying to make the left hand side, right? And you can see that p square plus 4q square equals to this. So we can write down this particular expression into form like we can write down 1 in the left side, okay, then plus 4q in the right side, and then 4q square on the right side, right? Yeah. So I have to erase some of the part from there so that you may be able to realize what will happen after that, you know, right? So can you please wait a second? Yeah, just wait a second. Yeah, I'm erasing this part, and okay, so I'm erasing this part, and now I can write down this particular part is, which is p square plus 4q square equals to, I can write down 1 as a 1 square, right? I'm just trying to make this right hand side as a perfect square. So I can write down 1 as 1 square and 4q as 2 times 1, right? 2 times 1 times 2q, right? I can write down is this a square plus 2ab, right? And I can write down 4q square as 2q whole square, right? So here you can see that p square plus 4q square is equals to 1 plus 2q whole square, right? Here you can see that the option number C is also exist here. So for this particular question, we will have two options which are B and D. So the correct options of the question, so the correct options of the question are option number B and option number C, right? So first of all, these questions may feel, you may feel that some of the part is little bit difficult, but I'm just trying to solve some of the questions related to the advanced level, right? There are some basic questions you guys already did in your 10th, in your primary education, but in this particular video we are just trying to solve some of the questions which may be in an advanced level, right? So these questions you may feel like, yeah, these questions are literally very hard, but that's not. If you do these questions in a systematic manner, you cannot have to think about the easiest question because you have already solved the hard question. That is why I'm just solving these questions, right? Okay, so let's move to the next slide, which is the nature of roots of a quadratic equation, right? I have already told you that in the first lecture that for the case of d less than 0, the roots will become imaginary. For the case d greater than 0, the roots will become real and distinct. We will discuss about this in a later one. And for the case of d equals to 0, it will be real, right? I'm just write down this condition. For d less than 0, we'll have imaginary roots, right? Imaginary roots for d greater than or equals to 0. So here you can see that there are two conditions applied in one condition, which is d greater than 0 and d equals to 0, right? So for that condition we'll have real roots, right? The roots will become real. So these are actually write down here from this particular part, this particular part, this particular part. So why for d greater than 0 the roots will be distinct, right? And for d equals to 0 the roots will be equal. We'll discuss in this particular lecture, right? So you know, by Sridhar Acharya's formula, right? By Sridhar Acharya's formula, what we'll get for the quadratic equation, which is ax square plus bx, right, plus bx plus c equals to 0. Obviously the conditions will be a, b, c should be real number and a should not be equals to 0, right? Then what is the value of x? The value of x will become minus b plus minus root under of b square minus 4ac by 2a, right? So we can write down this particular expression in the form which is minus b plus minus root under d by 2a, where d is equals to definitely b square minus 4ac. Am I right? Because I have already discussed about the discriminant, which is d, right? And the discriminant value is b square minus 4ac. So we can see that x has two values. One value is minus b plus root d by 2a and another value is minus b minus root d by 2a. Here you can see that these are the roots of the quadratic equation x square plus bx plus c equals to 0, right? So the condition is if d is less than 0, right? If d is less than 0, then alpha beta. So you can see, you know, right, alpha and beta are the roots of the quadratic equation. So here we can write down, since this is a root, this is also a root, we can assume that this particular expression, which is minus b plus root under d by 2a as alpha and minus b minus root d by 2a as beta. So these are the two roots. We are just renaming these two roots as alpha and beta, right? So if d is less than 0, so definitely root under negative number, right? Root under negative number is always belongs to the complex number, right? This is actually a complex number. This is actually an imaginary part. So definitely this total part will be an imaginary part. So alpha will be imaginary and similarly beta will also imaginary part, right? So we can say for d less than 0, the roots alpha and beta, I mean this particular guy and this particular guy will become an imaginary part, right? So this is the condition. And can you tell me what is the condition for d greater than 0? It is also very simple. I have already told you that alpha is nothing but minus b plus root d by 2. You can choose alpha as this part, beta as that part. There is no issue, right? You have to choose these roots as alpha and beta. So beta will become minus b minus root d by 2a, right? So if d is greater than 0, right? If d is greater than 0, definitely in the root part it will be a real number, right? You know, right, root 2 is a real, root 5 is real, but root over of minus 2 is not a real number. Root over of minus 5 is not a real number. These are actually imaginary number or sometimes called complex numbers, right? So if d is greater than 0, this root d will be a real number and b is also real. We have already told you that b is real, and this 2a, right, here it will be 2a. That part is also real because a is real, right? So we can say that this particular term and this particular term, both terms will be real, right? Am I right or not? Can you tell me in the comment section? That is real, right? So I'm just erasing the part because I have to write something. Okay, wait a second. Yeah, so I have to change the ink. Yeah, okay. So we know, right? So these are real, definitely real. So can you tell me why for d greater than 0 alpha beta are real and distinct? Distinct means they are totally different, they are not equal, right? We can write down alpha not equals to beta. Can you tell me why? I'm just write down here again alpha for giving you the understanding about why this is happening, right? So minus b plus root d by 2a, and beta will be minus b minus root d by 2a, right? So for d greater than 0 this part will be real, for d greater than 0 this part will be real, so the roots are real. But you know, right, here the conditions will be, suppose if we choose d as 2, right, then the root will become minus b plus root 2 by 2a, and the root will become minus b minus root 2 by 2a, right? So here you can see that alpha and beta are totally different. Here there exists a plus sign and there exists a minus sign. So alpha and beta are the different things, so we can say that alpha and beta are distinct, right? But if we put d as 0, right, if we put d as 0, then this total part root d will be vanished, right, will become 0. Then what will be the value of alpha? For d equals to 0, we will have the value is minus b plus root 0 by 2a, right? And definitely alpha will become minus b by 2a. For the case of beta, we know, right, for d equals to 0 it will become minus b minus root 0 by 2a, right? So it will become minus b by 2a, right? So here you can see that alpha and beta are same for d equals to 0, right? But they are real because beta, b and a are the real terms, right? So minus b by 2a is definitely a real number. So for d equals to 0, alpha and beta are real and equal, but for d greater than 0, alpha and beta are real and distinct, right? This is also very important part. And for d less than 0, alpha and beta are imaginary, and we'll discuss in further lectures or in this particular video that why this imaginary part will become so much, difference in these imaginary roots will be obviously distinct. You can add this particular term, that and distinct, right? You can say and distinct. For d less than 0, the roots will become imaginary and distinct. This is not necessary to say because imaginary roots are coupled roots, right? So if one root is of the form a plus ib, where a, b are real numbers definitely, then another root will become a minus ib. So these are different terms, but here we are just write down these things, right? If imaginary roots occur, they will occur in a pairwise. So a plus ib and a minus ib will occur, and they are definitely different because here you can see that plus sign is there, minus sign is there, plus ib exists, ib are not equals to 0, ib are not equals to 0. So definitely these are distinct, right? Okay, let's move to the next slide, which shows you that a note, right? What the note says: roots are rational. These implies and implied by d is a perfect square. Sometimes it is says if this particular if, it means if and only if. What does it mean actually? Suppose a exists if and only if b exists. I mean, we can move a to b and b to a. That is the exact thing what a if and only if, right? So here the given condition is roots are rational. This implies and implied by d is a perfect square, right? So just think about it. Suppose I'm just taking roots are rational, right? Roots are rational. I'm just talking about the quadratic equation only, right? Quadratic equations only. You don't need to think cubic equation, quadratic equation, biquadratic equation, quintic equation, linear equation. You don't need to think about that. You have to think about the quadratic equation, the polynomial equation, which has degree 2, right? So roots are rational, right? I'm just proving that roots are rational. That implies D is a perfect square, right? D is a perfect square, right? So again, that thing, we have to write down the roots, right? We know for the quadratic equation, the general quadratic equation, which is x square plus bx plus c equals to 0, we know that the value of x, that the roots will be minus b plus minus root under d by 2a, right? I'm not write down here as b square minus 4ac because we know, right, the value of d is nothing but b square minus 4ac, right? So think about it in this way, that what is rational number? First of all, rational number can be denoted like q. Rational number is a subset of a real number, you know, right? Very well. You can write down rational number is contained in real number, right? So what is rational number? Rational number is of the form p by q, where p comma q belongs to z and q not equals to 0. I will show you some of the examples of a rational number. Rational number can be 1 by 2, rational number can be 2 by 3, rational number can be minus 2 by 3, rational number can be 4. I can write down this as 4 by 1, right? So this condition actually hold, right? 4 is an integer, 1 is an integer, 2 is an integer, minus 2 is an integer, 3 is also integer, and you can see that the denominator terms, which is 2, 3, 3, 1, right? These are actually non-zero numbers. So definitely these numbers are actually one of the example of rational number, right? So you can understand what is rational number. So think about in this way, if d can be written as a perfect square, right? So d can be written as something integer value to square, right? Suppose d equals to 4, so 4 can be written as you can, you know, right, plus minus 2 ka whole square, right? You can write down 2 square, you can write down minus 2 square, right? So if d is a perfect square, so we know, right, square and root will be cancelled out, and it will become, this particular part will become an integer. So we can write down root d belongs to z. You know, right, what does it mean by z? Z means you can, you know, right, 0 plus minus 1 plus minus 2 plus minus 3 and so on. Sometimes it can be denoted like that, dot dot dot, minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on, right? So these are actually the integers, right? So if d is a perfect square, then square root will be cancelled out and we'll have only integer value, right? So this part will be integer, and this part is also a real number, this part is also a real number. So we can say that this will become a rational number, right? This will become a rational number. So similarly, you can say that if roots are rational, then definitely d should be a perfect square, and if d is a perfect square, if d is a perfect square, d is a perfect square, then that implies that roots, right, roots, and I can write down alpha and beta in the bracket because, you know, right, roots can be denoted like alpha and beta, right, are rational. You can write down anything in the place of alpha beta, but I am just generally thinking about this particular alpha and beta, right? So you can understand that if roots are rational, that implies and implied by d is a perfect square, right? That implies and implied by d is a perfect square. So before starting the second part, I have to erase that part because otherwise I haven't any kind of space in this particular slide. So that is why I have to erase that part, right? Yeah. So let's start the second part, which shows that roots are irrational if d is positive but not a perfect square, right? roots are irrational, right? Roots are irrational. Can you tell me what is irrational number is? Irrational number simply means we know, right? Real number is nothing but rational number union irrational number. Irrational number can be denoted at QC, or sometimes it is denoted by R minus Q, right? So if we actually deduct or subtract the rational numbers from the real number, the values we will have is called an irrational number, right? Irrational number can be denoted as root 2, root 5 by 2, right? E, pi, these are actually the irrational numbers, right? So this is one of the example of irrational numbers, but you can understand what does it mean actually, right? So here says that roots are rational number implies and implied by D is positive but not a perfect square, right? So I'm just proving one part, then I will prove the second part. So roots are irrational implies D is positive but not a perfect square, right? So what does it mean? D should be positive and D is not a perfect square. So again we have to write down the roots, right? Roots will be for the case of ax square plus bx plus c equals to 0. This is the quadratic equation. So the roots will become minus b plus minus root over of d by 2a, right? So if d is positive, here you know, right, d should be positive and d should not be a perfect square. If that will happen, then this total part will become irrational. Let me think about it. Suppose if we choose d equals to 3, so 3 cannot be written as perfect square, right? Perfect square of an integer. Here you should add one thing, of an integer, right? We can write down d as a d equals to 3 for root 3 ka whole square, right? Root 3 whole square. But root 3 is not a rational number or an integer number, right? So we cannot take integer, or you can say, suppose, wait a second, I have to take rational here, sorry for that. I have to take rational number of a rational number, right? Of a rational number here. So for the case d equals to 3, we cannot write down any x ka whole squares where x is a rational number. We cannot write down this, right? So since we can't write down this, it will become only root 3, and b is a real number, a is a real number. So you can understand that this total part will become an irrational number, right? Because it has two parts. One is opening with plus, another is opening with minus. So for the case of irrational number, we can say that d is positive but not a perfect square. Similarly, if d is positive but not a perfect square, then we can say that the roots are irrational. You can understand, right? If d is positive, because if d will be negative, definitely the total roots will become imaginary. So the irrational is not an imaginary number, it's actually a real number, right? It's actually one of the real numbers. So if d is positive, that is the necessary condition, and also not a perfect square, that is also a necessary condition. Those two conditions will be the necessary and the sufficient conditions to prove that the roots are irrational numbers, right? So you can understand what these two notes is very important, because if d is a perfect square, the roots will be rational. If roots are rational, then d will be a perfect square. If roots are irrational, d is positive but not a perfect square. If d is positive but not a perfect square, that implies roots are irrational, right? So you can think about it more deeply by thinking about the conditions, and also some of the examples you can choose arbitrarily from your textbook, from the internet, right? And you have to solve these things so that you can understand what does this particular mean, right? So for solving this, you have to try to find out the value of d, right? Okay, let's move to the next slide. Yeah, this is actually a question related to this topic. So this is also advanced questions. I'm write down here, right, advanced questions. But if you will understand these questions, definitely your mind will be shaping a lot, right? So you have to think about this. Here given that if a plus b plus c equals to 0, so the condition is given a plus b plus c equals to 0, right? This is actually given condition. You can understand, right? You know the given condition is a plus b plus c equals to 0, and a, b, c are rational number, right? And a comma b comma c are rational number, or we can write down a comma b comma c belongs to q, right? The rational numbers. Then the roots of the equation, these are rational, irrational, imaginary, equal. In order to find out the roots, the nature of the roots, whether this is irrational, these are irrational, these are rational, these are imaginary, these are equal, we have to just find out d. Why? Because if d can be written as a perfect square, then that will become rational. If d equals to 0, then it will be equal. If d isn't written as a perfect square, but d is a positive number, then it will become an irrational number. Those roots will become irrational number. If d is less than 0, so that will become imaginary number. I have already discussed those things, right? So I don't have to spend a lot of times related to this thing. So I have to find out the d, right? You know, for the quadratic equation ax square plus bx plus c equals to 0, what will be the value of d, right? Then d is nothing but b square minus 4ac. I have already told you, right? So for the case of this quadratic equation, I am writing down here so that you can understand what is this, right? X square plus c plus a minus bx. It looks like a mammoth size quadratic equation, but when I will trying to solve this question, it will become so much easy because I have the knowledge, right? And you may solve by your own, right? So for the quadratic equation, the value of d, I can write down discriminant, right? Discriminant d equals to, or you know, right, I have already told you it may be written as delta, which is equals to b square. So where the b lies, it is nothing but the coefficient of x. So here the coefficient of x is c plus a minus b. So I can write down this coefficient, which is c plus a minus b whole square, right? Minus 4 times a times c, right? A is nothing but the coefficient of x square and c is nothing but the constant term. So here, you know, right, the coefficient of x square is b plus c minus a. So I can write down here as b plus c minus a, and the constant term is a plus b minus c, right? So a plus b minus c. Okay, so I have to use the condition in this particular expression because this is literally a very big size question. I have to minimize the question so that I can understand what I have to do in future, right? So the given condition is here, you know, right? What is the given condition? Wait a second, I have to change the color so that it looks very great. It looks very great, right? So okay, so what is given condition? What is the given condition? Which is a plus b plus c equals to 0, right? From that condition, can you tell me what is the value of a plus b? It will be minus c, right? Because I can add on both sides by minus c. So we will get a plus b equals to minus c. Can you tell me what is the value of b plus c? It will become minus a, right? Can you tell me what is the value of a plus c? So it will be minus b. So I will use these three conditions, right? I'm just taking star. So using star, right, we will have d equals to, right, wait, d equals to, we can write down this c plus a. Here you can see a plus c is nothing but c plus a because a, b are real numbers, So we can write down as a plus c as c plus a, because the commutativity property will be applied here, right? So a plus c is nothing but c plus a, so we can write down in the place of c plus a as minus b, right? And this is minus b, so this part whole square minus 4 times here. Can you tell me what is the value of b plus c, which is minus a? So I can write down here minus a, and minus a is also exist here, right? Exist here. And can you tell me what is the value of a plus b? It is obviously minus c, here you can see, right? So minus c and minus c, so you can see that minus b will become minus 2b, that part's whole square minus 4 times here, you know, right? Minus 2a, here is minus 2c. So what is the value of this particular expression? Since the square is there, so minus part will be cancelled out, it will become plus, and 2 square is 4, and b square will be b square, right? And 4, you know, right? Minus times minus will be minus, so I can write down 4 times 2 times 2, right? It will be definitely 16 AC, right? So wait a second, I have to erase the part. Yeah, I have to erase the part, right? Yeah, so yeah, okay, let's move to writing down something. Yeah, so you can see that the value of d is nothing but 4b square minus 16 AC. So I can take common as 4, so we'll have b square minus 4 AC. So we can't say that this particular term is whether positive, whether negative, whether equals to 0. So we have to use again a condition from the given condition. Here I am just writing down the given condition, which is a plus b plus c equals to 0. So can you tell me what is the value of b? It is nothing but minus a minus c, right? So I can write down the place in the place of b as minus a minus c. So it will become minus a minus c, that part whole square minus 4ac, because I'm just trying to make this particular expression into a perfect square form, right? So it will become 4 times, I can take common from this particular part, so it will be minus a minus c, that part whole square, right? Minus 4ac, right? So I can just here this will be plus, right? So I can just neglect this negative symbol, because here, you know, right, square is there, right? So that will become a plus c whole square, right? Minus 4ac. So can you tell me what is the value of a plus c whole square? You know, right? It will become a square plus 2ac plus c square, and minus 4ac is there, right? So I have to write down this here. So 4 times, you know, right, a square plus c square and 2ac minus 4ac will become minus 2ac. So I can write down this as a square minus 2ac plus c square, right? So we can write down this particular expression in the form which is a minus c, that part whole square, right? So you know, right, anything square and with multiplied with a positive quantity is either 0 will happen when a equals to c will be there. We can't say why a equals to c will may be there, a greater than c may be there, a less than c may be there, but whatever may be the case will be there, that part, that quantity, whether that quantity will be 0, whether that quantity will be negative, whether that quantity will be positive, that total part will be always greater than or equals to 0, right? Equals to 0 may happen, greater than 0 may happen, right? So that part will become greater than or equals to 0. So d is what? D is greater than or equals to 0. So can you tell me what is the condition hiding behind that? For the case of d greater than or equals to 0, we can say that whether the roots will be rational or equal. You know, equal is one of the case for when a equals to c will be happen, but here, you know, right, a equals to c is not there. We can't say that a equals to c will be there. it may be there, it may not be there, but what it may be the case, for the case of d greater than or equals to 0, the roots will become here you can see that we can write down, wait a second, hold on, we know, right, d equals to, here is given 4 times a minus c whole square, right? So we know 4 as a 2 square, right, and a minus c whole square, so we can write down, right, 2 times a minus c, that part whole square, right? So d is nothing but a perfect square, right? So for the perfect square, we know the roots will become rational, right? That is the actual answer. And root may be equal for the case of a equals to c, right? But roots are rational. This is something which always happens, right? And we know, right, 0 is a part of rational number. If that will be 0, if d equals to 0, then roots may be roots real and rational, and also can you tell me, like, roots will be minus b by 2a, right? These are equal roots, and also these are rational numbers, right? Because b and a are the real numbers, right? And also rational number is given here. So after applying this condition, you can say that these are rational numbers. Have you understood? I'm just trying to tell you again that here a, b, c are rational number. So if a equals to c will be there, then if d equals to 0 will be there, then there are two roots will exist, which are minus b by 2a, minus b by 2a. But these are rational because b and a are rational, which is given. So what it may be the case will happen, rationality will be there. So the option A is the correct option. So the correct option is A, right? You can understand that this is little bit this is literally, I can understand that this may be a difficult problem, but you can understand what this trying to say, right? Okay, so okay, let's move to the next question, which is also kind of a good question. You can consider as a good question. And the question says the value of m for which the equation this mammoth size equation is given to you, which is 1 plus m times x square minus 2 times 1 plus 3m times x plus 1 plus 8m equals to 0, has equal roots, right? So basically you have to try to find out the value of the discriminant, which is d, right? So if d equals to 0, I have already discussed about the theory related to the discriminant, which is if d is equals to 0, then the roots will become equal, right? So this mammoth size expression of a quadratic equation may seems like little bit may seems you little bit anxiety, but let me write down the quadratic equation first, which is 1 plus m times x square minus 2 times 1 plus 3m times x plus 1 plus 8m, right, which is equals to 0. So I have to find out the value. I have to try to solve the part which is d equals to 0, since the given condition is the roots are equal, right? So since the roots are equal, since the roots of the given quadratic equation are equal, right, then d equals to 0, right? And you know what is the value of d? D is nothing but for the quadratic equation ax square plus bx plus c equals to 0 is b square minus 4ac, where b is the coefficient of the x and ac would be the coefficient of x square and the constant term respectively, right? So we can write down d as minus 2 times 1 plus 3m whole square, right? So we can write down minus 2 times 1 plus 3m, that part, sorry, that part whole square minus, right, b square minus 4 times ac, right? So 4 times 1 plus m into times 1 plus 8m, which is nothing but equals to 0, right? So what is the value of this particular expression? I have to solve this expression, right? So you know, minus 2 whole square will become 4 because minus will be there cancelled out, minus will be cancelled out, and it will become 1 plus 3m that part whole square, right? And minus 4 times, wait a second, hold on. Yeah, so I have to take or, right, because it will become 1 plus m, sorry, wait a second, yeah 1 plus m times 1 plus 8m, right? 1 plus 8m, which is equals to 0, right? So this is the condition. So we can write down this as, we can take the common part, right, 4. So if we'll take common, it will become 1 plus 3m a whole square minus 1 plus m and 1 plus 8m, right, equals to 0. So if we just divide both sides by 4, it will become 1 plus 3m whole square, right, minus 1 plus m times 1 plus 8m equals to 0. So if I just express this particular term, we will have 1 square, which is 1, plus 2 times 1 times 3m, right, plus 3m whole square. And if I just multiply this part, we will have 1 plus 8m plus m plus 8m square, right, equals to 0. So we will have 1 plus 6m, right, plus 3m whole square. I can write down this as 9m square, right, minus 1 minus 8m minus m, it will be minus 9m and minus 8m square, because I have to multiply minus by negative symbol, right? So 9m square minus 8m square will become m square, right? Plus 6m minus 9m will become minus 3m, right? And I can cancel out 1 and minus 1. So we will have m square minus 3m equals to 0. So if I will take common m, so it will become m minus 3, which is equals to 0, right? So we know, right, if factorial will be there, so either the left part, which is m, will be 0, or the m minus 3, that part will be 0, right? It is nothing but an inclusive OR. I mean, we can take both parts, right? If one of them happened, that will be okay. If both of them will happen, that is also okay. So m minus 3 is equals to 0. So can you tell me what is the value of m? It will become 3, right? So we have two values, which is 0 and 3. So let's look into the options. Here you can see that A option is correct option, but B is not correct because 1 is not there. We didn't get any value of m as 1, right? We didn't get 2, but we get D, right? So the correct option would be, so the correct options are A, comma D, right? Here you can see that A, comma D are the correct options, right? Okay, let's move to some of the theories for which you will be able to understand what it is just trying to, putting what it is actually trying to say. The first theory shows like if A and C are of opposite sign. I mean, what is A and C? Sometimes people will say. So basically you have to set the quadratic equation, which is x square plus bx plus c equals to 0. This is the general quadratic equation. This is the general quadratic equation, right? So this is the general quadratic equation. So a means nothing but the coefficient of x square, and c is nothing but the coefficient, the constant term. If the coefficient of x square and the constant terms are of opposite sign, then the roots must be of opposite sign. Then the roots must be of opposite sign. Let me break out this part into segment, right? You know, the roots will be minus b. By taking positive, it will be minus b plus root under d, right? And in the place of d, we can write down b square minus 4ac, right, by 2a. And another root is minus b, right, minus root under b square minus 4ac by 2a, right? So what it's trying to say, a and c are of opposite sign. That means if a is positive, then c is negative, right? Are of opposite sign means if a is positive, then c is negative. If a is negative, then what will be the case of c? It will be positive, right? So you know, right, positive times negative, if we just multiplied a times c, can you tell me what is the sign of a times c? The sign would be positive times negative, it will be negative, right? If we just multiply it for the case a times c, when a is negative and c is positive, then a times c will become also negative, right? So you can see that a times c is negative, a times c is negative. So if a times c is negative, and if we multiply it by 4, definitely 4ac will be negative, and negative times negative, b square minus 4ac will become a positive number, positive quantity, because this part is negative, and if we multiply it by negative symbol, it will become a positive number, right? It is become a positive number, right? So if it is a positive number, then root over of d, which is a positive quantity, is nothing but a positive number, right? Root under of a positive number is nothing but a positive quantity, right? So you can see that if this part will be a positive number, let k be the term, right? So the roots will become minus b plus k by 2a, and the second part will be minus b minus k by 2a, right? So the roots must be of opposite sign, right? Opposite sign. So here you can see that the roots are the opposite sign, because I can take, right, I can take these things. You can see the roots must be an opposite sign, because here that part is positive quantity. If that part is positive quantity, then definitely these are distinct root, obviously distinct root, and they are of opposite sign, right? So you can understand what I'm just trying to prove this particular part by just taking the value, by just trying to find out the what is d, right? Yeah, that's true. So let me first erase that part, so that I can actually trying to, so that I can just trying to show you the condition for the second condition, right? So yeah. Wait a second. Yeah, let's using greens, right? If x square plus bx plus c equals to 0, a quadratic equation is given to you where a, b, c are real numbers, right? And the extra condition is always and a should not equals to 0. That is a condition you have to remember in your mind. So if ax square plus bx plus c equals to 0, where a, b, c are real numbers, has one root which is p plus iq, then the other root will be p minus iq. Hence the imaginary roots occur in conjugate pair. So let me introduce this thing in a different way, right? If we know, right, imaginary roots means the d is negative, right? So if d is negative, then the roots will become minus b, suppose, plus something imaginary part by 2a, and another root will become minus b minus something imaginary part by 2a. So we can write down this part as minus b by 2a plus something imaginary part by 2a, right? And also we can write down this part as minus b by 2a minus something imaginary part by 2a. So here you can see that if this can be written as p, if this can be written as p and it has iota part, right, in the imaginary part, definitely it will happen, because we know, right, root under negative symbol will become root under that positive symbol times iota, because root under minus 1 is nothing but iota. Let me take an example. Root under, what is root under minus 5? We can write down this particular part as root 5 times iota, right? So that part will become another q times iota, right, which is iq or qi, you can write down this. So if p plus iq is there, definitely we can say this part is also p, and here minus symbol is there, and this is also qi, right? So p minus qi is also there. So if p plus iq will be a root, then we can say without having any kind of hesitation that p minus iq will be another root, that is called the second root of the quadratic equation. So these are actually conjugate pairs, right? P plus iq, p minus iq. So if roots are imaginary, then they will occur in pair, and they are the conjugate pairs, right? That is something which is literally very understandable, right? So let's move to the next slide, which tells you that if ax square plus bx plus c equals to 0, where a, b, c are rational numbers, has one root p plus root q, then the other root will be p minus root q. You know, right, what is third root? So third root are actually looks like this, p plus root q, and another root will become p minus root q. Hence irrational roots occur in conjugate pairs. What is roots? Irrational roots. In the coefficient are rational, if the coefficients are rational. So let's break this part into separate way, which is, we know, right, for the case of x square plus bx plus c equals to 0, the roots will become minus b. For taking positive symbol, it will become minus b plus root under b square minus 4ac by 2a, and another root will be minus b minus root under b square minus 4ac by 2a, right? So if that part is not a perfect square, what is the condition of irrational roots? You guys already know that for the condition of irrational roots, that discriminant part, which is b square minus 4ac, should be positive, and that should not be a perfect square. So if d, which is equals to b square minus 4ac, is a positive symbol and not a perfect square, then that part will become root under something which cannot be breaked out, right? So I mean, like, if root 3 is there, it can't break out. If root 2 is there, you can't break out. You know the value 1.41 something, and that has 1 point something, but this is actually irrational number, right? So this is actually root something. So I can write down this part as b plus, suppose I can write down root k, right? You can write down this part as a root k, right, by 2a. So you can see that I can write down minus b by 2a and plus root k by 2a, right? Similarly, I can write down this as minus b by 2a minus root k by 2a. So if I will take this part as p, and if I will take this part as root q, definitely the root will become p plus root q. Similarly, I have to take this part as p and this part as q, so root q. So definitely this will become p minus root q. So the another root will become p minus root q. So you understand that for irrational roots, if one root will become p plus root q, another root will also be p minus root q, where pq are real numbers. We will discuss it further later on, but that is the actual condition. And the conjugate pairs, if the coefficients are rational, right, it is given that it occurs in conjugate pair if the coefficients are rational, right? So ABC, that the coefficient of x square, the coefficient of x, that the constant terms, I mean this is also the coefficient of x to the power 0, right? The coefficient must be a rational number, right? So if that coefficient will be a rational number, the roots will become if the roots will become irrational, then if one root will be p plus root q, then another root will become p minus root q, right? So this is all about for the lecture 2. We'll discuss in the later videos about the quadratic equation. We'll solve some of the examples, some of the theories. We'll understand some of the theories and some problems related to these theories. So that is all about for the today's lecture, and keep trying, keep your best, doing your best for understanding the logic hidden behind mathematics. And okay, thank you for attending the lecture. We'll meet soon. Thank you.